Hi everyone, welcome back to Multilingual Natural Language Processing. In previous lectures, we talked about transfer learning in multilingual NLP applications, such as sequence labeling or machine translation. So how to take corpora or linguistic annotations or linguistic properties and statistical models in resource-rich languages and to transfer them or to adapt them into resource-poor scenarios. And we discussed that to measure transferability of a language, we need to have a notion of similarity between languages. And one solution that we talked about, for example, was to pick a transfer language which is resource rich and has the largest vocabulary overlap with the target language. Today, we are going to delve deeper into why some languages share vocabularies and why these shared vocabularies can grow or shrink over time, and how to computationally model lexical similarities across languages. So imagine a hypothetical tribe, say a few thousand years ago, living in what is now called Miami in Florida. They live in isolation and they have their own language developed in isolation. At the same time, another tribe is living in what is now called Pittsburgh. They also have their language developed in isolation. So the Pittsburgh tribe decides that they are tired of eternal winter and they want to migrate to Florida. And there they meet the Florida tribe. So they want to communicate, to exchange knowledge and resources. But not only they speak different languages, their lexicons don't match. The Pittsburgh tribe doesn't have words for alligator and coconut. The Florida tribe doesn't have words for sled or corn. So when they trade coconuts or corn, they use names from another language. But they adapt these words into their own language, into the pronunciation of their own language, into morphology or grammar. So this linguistic phenomenon is called borrowing, or borrowing of words or sounds or grammar from one language into another. And this phenomenon is as old as language itself. It happens as a result of language contact, like I described in that hypothetical example with the two tribes. If you find yourself particularly interested in the linguistic aspects of what I will be talking about, you can read this introductory book by Sarah Thomason on language contact. She describes language contact simply as the use of more than one language in the same place at the same time. Language contact requires contact between speakers of different languages and does not require multilingualism or bilingualism or fluency in those languages. Turns out that language contact is one of the primary factors that drive language change. In general, there are two primary types of factors that affect language change. There are language internal factors and language external factors. An example of language internal factors would be a process of simplifications and the change of words to ease their articulation, to ease their pronunciation. And some words change meaning. And language contact is a very important factor also in language internal, but also language external reasons for language change. Susceptibility of a language to borrow from other languages is determined by both linguistic and socio-political reasons. Linguistic considerations involve attempts to fill a lexical gap, a word that doesn't exist in a language, for a concept, for example, that represents new technology, or words related to foreign culture, or words related to foreign flora and fauna. like with the examples of corn and sled. Second, socio-political factors that are determined by political and social prestige. Speakers borrow from a higher prestige group, and if they borrow from a lower prestige group, those words usually have derogatory meaning. So why do we talk about it in a multilingual NLP class? Because understanding the historical process of language contact and language change can help us model cross-lingual similarities across languages. For example, Swahili is one of the most spoken languages in East Africa. There are more than 100 million people who speak Swahili. Due to more than 1,000 years of language contact, the long history of Indian Ocean trading and the influence of Islam, a large chunk of Swahili vocabulary, about 40% of it, originated from the Arabic language. And more generally, here is how pervasive borrowing is. These are resource-poor African and Asian languages. And historically, they borrowed from resource-rich languages, such as Arabic, Spanish, English, and Chinese. And these are languages spoken by billions of people, and they don't have enough resources. But 30 to 70% of their vocabulary can be actually mapped from into historically, geopolitically important languages. So languages like Arabic, Spanish, English, Chinese are resource-rich, but also they are donor languages to resource-poor languages, not by chance. These big languages historically occupied large parts of the globe. They were in contact with these resource-poor languages through trade, colonization, slavery, religion, and so on. So if we can bridge between resource-rich donors and resource-poor recipients, we can project resources and improve NLP applications in multiple languages. So here we will transfer, so we will ask a practical question. Based on the knowledge of language contact or historical changes of languages, how to bridge across languages. More practically, we need to identify words that are orthographically or phonetically similar across different languages, since they are likely to be mutual translations. Here are some examples of lexical borrowing across typologically divergent languages like Arabic and English. The problem of modeling or cross-lingual mapping of borrowed lexicons is a sub-problem of a more general problem of cross-lingual lexicon induction. Of course, if we already have manually constructed dictionaries, like in the case of Arabic in English and English in this example, we can just use them. Or if we have large parallel corpora, like we discussed in previous couple of lectures on MT, we can collect large bilingual dictionaries using unsupervised approaches. And we'll talk about such approaches later in the course, probably next week. But techniques that we are talking about today are relevant for resource-poor settings, to bootstrap resources and cross-lingual translations, even when no large monolingual corpora are available for a language. In addition, even in resource-rich settings, these techniques are useful to extract a long tail of new named entities that constantly appear in a language. So we can treat the problem of cross-lingual lexicon induction as a discriminative or as a classification problem. In this case, we need to identify the translated counterpart in another language in the target vocabulary, given an input word. So this is one of those multi-class classification problems. More commonly, the problem of cross-lingual lexical mapping is addressed as a string transduction problem. We can train a model that, given an input string in one language, can generate a plausible counterpart string in another language. So it is like a character-based translation. There are several types of different techniques. And to understand why we have different techniques for cross-lingual lexicon mapping, we can look at lexicon structure in the context of language contact and in terms of the evolutionary history of the language. Roughly, every language lexicon can be divided into 4 strata. Core lexicon words, these are words that were in the language when the language was born. For example, beer and bread in English. Then 2 strata include words that are borrowed from another language, but they are assimilated in the language. So fully assimilated words or partially assimilated words. So those words, although their origin is from another language due to language contact, they do not sound like foreign to native speakers. For example, words like cookie, sugar, coffee, and orange. And finally, there is a peripheral stratum. So this stratum, where we are talking about foreign words that are also sound foreign, like names of places and some specialized terms. So transliteration models peripheral vocabulary. These models proper names or specialized terms. And crucially, transliterated words are foreign words written in a local orthography. Whereas modeling borrowed words or cognates is more related to phonological modeling, because these words are assimilated in the target language, or they have developed with the development of the language in the case of cognates. So cognates are core vocabulary words, and they involve phonological, and not only, if we want to map between the 2 languages and identify cognate words, we would need to model phonological and morphological in addition to orthographic adaptation. And in the case of borrowed words, we also need to model phonological and morphological adaptation, but unlike with cognates, language contact and the lexical borrowing can happen with very different typologically unrelated languages. So the assimilation process and consequently the modeling is much more complex, because these languages, pairs of languages can be very divergent. So although modeling cognates can be easier, in practice, this has limitations. Because eventually we want to bridge or model lexical relationships between 2 languages to be able to project translations or annotations from resource-rich to resource-poor language. But in the case of sister languages, there are full language families, for example, like Bantu languages, that do not have a single resource-rich language in the family from which we can project resources. So crucially, there is no clear-cut separation between these 4 strata that I described, between core, assimilated, and peripheral lexical items. It is more like a continuum, depending on the level of assimilation of foreign words. So words are imported and they start from transliteration, then speakers may use code switching, and gradually words become native in the language. So we start with the most commonly discussed problem of modeling transliteration. Transliteration is an important problem widely studied in machine translation and in cross-lingual information extraction. Transliteration is extremely useful because no matter how large is our data, there is a long tail of named entities, new words that we need to be able to translate. These words are a primary source of out-of-vocabulary terms, for example, in machine translation, even in a large corpora. A number of model-based methods for machine transliteration have been developed in the past. Such models assume that character sequences in the source orthography correspond to predictable character sequences in the target orthography, possibly depending on context. Earlier approaches, so late 90s and early 2000s, focused on string transduction using probabilistic finite state transducers. And then newer architectures were introduced that focused on noisy channel approaches, commonly used in pre-neural statistical machine translation. So again, these are just character-based machine translation methods. Then some models additionally assume that such correspondences are influenced by phonetic information. And later, unsupervised approaches focusing on decipherment or expectation maximization based approaches were introduced to reduce the dependency on parallel data. Among discriminative models, the most successful class of models is conditional random fields, or CRFs. These models perform local string rewriting in the target language. More recently, neural network-based models for transliteration emerged, and naturally they started from simple sequence-to-sequence models like LSTMs with attention, and then evolved to LSTMs or transformers that also focused on insertions, on modeling insertions and deletions between the letters between the two languages. And more recent interesting studies focus on transliteration and subsequent morphological adaptation or morphological reinflection. So the focus of this work, for example, is on how to inject monotonicity as inductive bias in to learn latent alignment to align jointly with transduction. So how do we evaluate transliteration models? There are typically 4 types of intrinsic evaluation commonly used. They are well summarized in this report in a recent task on named entity. This is a shared task on named entity transliteration from 2018. So these are 4 measures. Some of them focus on exact match of transliterated word. Some of them focus on similarity of 2 strings or the location of the word in the n-best list match. So the first one focuses on exact match, on the accuracy or exact character match of the top one generated candidate for transliteration. The second is the mean F-score metric, and it measures how different on average the top transliteration candidate from its closest reference. And this is F-score metrics that uses character level precision and recall calculated based on the length of the common longest subsequence. Next, MRR, mean reciprocal rank, is a standard evaluation approach in ranking algorithms. It tells approximately the average rank of the correct transliteration in the list of candidates. And the mean average precision measures the average precision in the n best list candidates. Of course, transliteration models are best evaluated in downstream evaluation. They can be incorporated into downstream tasks such as machine translation or cross-lingual question answering. And they can be used off the shelf at pre-processing stages to augment training data, or as post-processing, we can transliterate named entities instead of using a copy mechanism. In terms of resources, a useful corpus of transliterated named entities was recently published at LREC 2020. It aggregates 1.6 million named entities across 180 languages. And these are aggregated across multiple public data sets, but unlike those data sets, they have a unified representation. This is a very useful data set. Okay, moving to a second type of models of borrowing and cognate models. So, as I mentioned, those two types are more challenging from the modeling perspective, but they're also very useful to do because unlike transliteration models, they really need to model more common content words in a language rather than new or rare named entities. Okay. So here are examples of phonological and morphological adaptation. Again, between two languages, Arabic and Swahili. Despite intense integration of Arabic in Swahili vocabulary, you can see that multiple morphophonological processes are going on in this adaptation. So these are two very different languages, first in orthography, but then in phonology. For example, Arabic has 5 syllable types and allows consonant clusters, whereas Swahili requires open syllables. So during adaptation, necessarily vowels are inserted between consonant clusters. Additional adaptation includes vowel shortening, consonant deletion or degemination, and the sound substitution, so consonant adaptation. And epenthesis means insertion. Degemination means deletion of double consonants. Also, these are two morphologically very rich languages, but very different languages. So when words are borrowed from Arabic, Arabic morphology prefixes are removed, but optionally. And then on top of this, Swahili morphology is applied. So it is possible that there will be a Swahili prefix and then Arabic prefix and then the word itself. Since borrowing is a pervasive linguistic phenomenon, it is also a fundamental research topic in linguistics. There are hundreds of papers and books on borrowing in specific language pairs. This research can potentially be used to build linguistically informed, better designed models that require less supervision than linguistically naive models. So in terms of modeling, the majority of prior work focused on automatically learning phonological mapping between the two languages, and use this mapping to learn phonological and semantic similarities between the languages. So there are several types of generative models for cognate identification that focused on diachronic processing. So again, identification of cognates. and the evolution of, they modeled evolution of words across a phylogeny. There are not too many models of loanword detection, and the prior approaches focused on synchronic processes and the morphological and phonological assimilation in typologically different languages. Again, in terms of resources, a large-scale database of cognates was released relatively recently at ACL 2019. Cognate pairs in this case were extracted using similar techniques. So I think this was phonologically weighted Levenshtein distance between phonetic sequences. So we automatically learn phonological mapping and the likelihood and apply some weighted edit distance in addition to semantic similarity. And these cognates were collected from existing databases such as WordNets across languages. So although lexical borrowing is linguistically well studied, in NLP there are not too many resources and not too many approaches to modeling borrowing. So it's relatively kind of there are many opportunities in this field. And these databases aggregates examples from linguistic research. And it's not complete, it focuses only on 41 languages, but for those languages, it has a lot of examples of borrowed words. Finally, I want to mention that there is a large space of related research on multilingual word embeddings learned monolingually and then projected into a common space using techniques like canonical correlation analysis, or multilingual embeddings learned jointly, or word embeddings that incorporate morphological and phonological knowledge, and so on. So there are hundreds of papers of word embeddings, and we can use this research to also extract mappings across languages or bridges across languages. For example, by doing a nearest neighbor search to find mutual translations, and also measuring orthographic or phonetic similarities between pairs of languages. And we will discuss these approaches in more detail next week. So to summarize, we talked about what is language contact and a very quick overview of existing approaches to bridging between lexicons of two languages. For the class discussion, you will need to look into some language. For example, you can pick a language that you speak and read a little bit about the history of contact for this language. And in particular, try to see if this language influenced other languages. So can you learn about other languages that historically borrowed words from your language? And if yes, can you find specific examples of words? And look at their phonological or morphological adaptation and tell us if you could recognize these loanwords in other languages based on their new form. And also maybe look at their semantic orientation and think about the socio-political status quo between speakers around the time when these languages were borrowed, and tell us if the sentiment of a word, for example, correlates with international relations between languages. So overall, tell us what you can find about specific words that are in the intersection between the language that you chose and the language that borrowed from your language, and tell us something about these pairs of borrowed words. And of course, each of these items is optional. You don't have to fill all of them. Okay, so thank you and see you tomorrow in the class.